Hello! In this lesson, I will present an engineering approach to rocket design using the general example of upgrading a ballistic missile to a guided missile. Because of the problem at hand, I want to go into the details of the tasks themselves or their solutions. By the way, it is worth realizing that an engineer is a person who solves technical problems by applying scientific methods. When designing a missile, in general any technical object, go through the following scheme of the stages. Of course, the scheme is not strict and can be modified as needed. In the first step, a clear and concise description of the problem should be created. In the case of our missile, it is to introduce a control system into the missile to control its flight. A precise description of the problem is prepared in the design documentation, such as in documents like technical conditions. In the next step, we preliminarily identify the elements that constitute an important role in solving the task. In this case, it may be the need to change the design of the missile to add a control system, changing the front streamline. A ballistic missile has no room inside for additional components. Another element may be the choice of aluminum control system, classic or cardinal system, etc. The problems themselves are many and require a separate special analysis of the issue. Then we create a solution model for a problem posed, along with assumptions and constraints. Here, for example, there can be a proposal for a proportional control algorithm and constraints of which may be the structural capabilities of the rocket and thus its maneuverability. Further, on the basis of the above work, experiments are planned from which data are collected for verification. Experiments can be different, while the simplest idea for such research is either dynamic shooting tests on the firing range with a missile armed, for example, with telemetry and collection of information during actual flight. Such tests are expensive and time-consuming. They shouldn't already be the final results of the work, or harder in the loop tape tests, for example, laboratory tests. The above three steps usually require many iterations. With each pass, the model needs to be refined, optimized, and changed. Therefore, to simply this is very important to plan the experiments well and then the data analysis. It is also important to collect the right data and the amount of data. Another work on the project is related to modeling the problem in the model we have adopted. This is to solve our task. For example, the flip speeds of the radars and their swing angles can be changed in order to accomplish our task as accurately as possible. With further parameter settings in the model, another experiment is conducted to confirm the correct solution to the problem and its square. Here you can think about physical testing of the rocket in flight. At the end, we draw conclusion, and if the project was successful, we take further action. For example, we get ready to produce a rocket. If the final project received a negative evaluation, we should also draw conclusion from the work and take action in accordance with the task contract. To summarize, an engineering method is an activity that combines a given problem with its elements that affect its solution, and it also combines a model and experiment. It is intended to verify the correctness of the model as well as its solution. A very important part of the engineering methods in statistics, which collects, represents and analyzes data for decision making and problem solving, then designing new products or upgrading old ones. I will talk about these issues in separate lessons. Thank you for your attention.